Hi everybody. In last lecture we have studied about bisection method. Okay. Now in today's lecture we are going to study some examples related to bisection method. In that first example is find the root of the equation x log x is equal to 1.2 by using bisection. Now in this we have to first consider f of x is equal to, now here function is given x log x is equal to 1.2. okay, so here f of x is equal to written as x log x minus 1.2. it can be written as x log x minus 1.2. okay, so now we want to find the root of the f of x is equal to 0. okay, so you may also write it as x log x minus 1.2 equal to 0. okay, now first we find the interval in which f of x lies. okay, so here we have to find the value of x such that it should be less than 0 and after it should be greater than 0. okay, so if we consider f of 2 is equal to, or for f of 1 if we find f of 1 is equal to, it will be 1 into log 1 minus 1.2. okay, so and log 1 value is 0, so it will be 0 minus 1.2 is equal to minus 1.2. okay, so for f of 2 it will be 2 log 2 minus 1.2. okay, now here you can find 2 log 2 on calci as, here if you consider 2 log 2 minus 1.2, it will be equal to, now here you have to make a bracket here, 2 log 2 minus 1.2, it will gives us as minus 0.5979. so here you can write minus 0.5979. okay, which is approximately near value, or after we consider which interval is for f of x. Now for f of 3 it will be 3 log 3 minus 1.2. okay, so here now to find 3 log 3 minus 1.2, it will be equal to, if you see it is 0.231 and 313, which is greater than 0. okay, so from these two values f of 2 and f of 3, you can say that f of x lies in interval 2 and 3. okay, f of 2 is equal to twice log 2 minus 1.2, which is equal to minus 0.5979, which is less than 0. okay, f of 2 is less than 0, and for f of 3 is equal to 3 log 3 minus 1.2, which is equal to 0.2313, which is greater than 0. okay, from these two values you can say that f of x lies in interval, or you can say that f of 2 into f of 3 is less than 0, because product of these two, it is negative and it is positive, so its products will be negative and it is less than 0, or that is f of 2 and f of 3 have opposite signs, so you can choose as, hence root lies in interval 2, 3. okay, now first initial approximation is first step, or you can write it as initial approximation, it as we take x naught is equal to, here values a and b is 2 plus 3 divided by 2, so it will be 5 upon 2. which is equal to 2.5. Okay, so we draw here a line. Here you have to write point, or you can write f of x lies in between 2 and 3. Here it is for 2, f of 2, it is less than 0, which means it is negative value of f, and here value of f is positive at 3. Now here 2.5 is midpoint of interval 2, 3. Now we have to check the value of 2.5 is positive or negative. So f of 2.5 is equal to, here we have to put value of x as a 2.5. So it will be 2.5 log of 2.5 minus 1.2. Okay, so it will be gives, by using calculator you have to find the values of f of 2.5. So it will be 2.5 into log of 2.5 minus 1.2. So its value is minus 0.2051. Its value is minus 0.2051. Okay, so here value of f at 2.5 is negative. Okay, so x0 is not a root, it which is less than 0. Therefore you can say that x0 is not a root. Okay, so you have to consider the next interval or an iteration first. In iteration 1 you have to say that here we can see that from this line f of 2.5 and f of 3 are have opposite signs. So you have to choose an interval from f of 2.5 to 3. So in iteration 1, so our interval will be from 2.5 to 3. So f of 2.5 and f of 3 have opposite signs. Therefore roots lies in interval 2.5 comma 3. Okay, so hence we get x1 is equal to, you have to write x1 is equal to, here value of a and b are now 2.5 and 3. So we have to add 2.5 plus 3 divided by 2. So which is equal to, it will be 5.5 divided by 2, which is 2.75. Okay, so f of 2.75 is equal to, so we have to put value of x as 2.75. So it will be 2.75 log of 2.75 minus 1.2. Okay, so now on calculator you have to make a calculation. So here calculation will be 2.75 into log of 2.75 minus 1.2. Okay, so its calculation is, here it is 10 raised to minus 3, which means it is positive now. 0 point, its calculation is written as, here it is in the power, it is 10 raised to minus 3. Okay, so its calculation will be here, and it is positive term, so it can be written as 0.00816. Okay, so which is greater than 0. Okay, now here we have selected an interval from 2.5 to 3. Okay, and at 2.5 value of f is negative, and at 3 it is positive. Okay, now center of this 2 is 2.75. Okay, we have to find the midpoint at each iteration. Okay, so now at 2.75 function value at 2.75 is greater than 0. Okay, so here it will be positive. So you have to choose an interval such that it should have an opposite sign. So we have to choose an interval 2.5 to 2.75. Okay, so that it will be negative and positive. So here you can say that x1 is not a root. x1 is not a root, so we go to next iteration number 2. So in that you have to define new interval. It is you from this above calculation you can say that f of 2.5 and f of 2.75 have opposite signs. So you can say that root lies in interval 2.5 to 2.75. Okay, so hence we can write, or we get x2 is equal to 2.5 plus 2.75 divided by 2, and its calculation, after calculating, it will be 2.625. okay, now we have get value of x2 as 2.625, so we have to find f of 2.625. so here we draw next interval as root lies in 2.5 and 2.75. At 2.5 it is negative value of f, and at 2.75 it is positive. Okay, now for midpoint of this 2 is 2.625. We have to check the value of f at 2.625. so at 2.625 it can be written as 2.65 log of 2.625 minus 1.2. okay, so you have to do a calculation on calc. So here again 2.625 into log of 2.625 minus 1.2, which will gives us, here it is negative of minus 0.0997. okay, so here you write negative, it is 0.0997, it is less than 0. okay, so value of f here it at 2.625 is negative. So here you can write x2 is not root. okay, so in next iteration number 3 you can say that here now you have to choose an interval, so you have to choose one negative value of f and one positive, so you have to choose an interval in this as 2.625 to 2.75. okay, so here you can say that f of 2.625 and f of 2.75 have opposite sign. So root lies in interval 2.625 comma 2.75. okay, so you can say that root lies in interval here we have said that root lies in interval 2.625 and 2.75. therefore we have x3 is equal to 2.625 plus 2.75 divided by 2, and it will, after calculation, it is, so you do it on a calculator, so it will be 2.625 plus 2.75, which is equal to 5.375 divided by 2. It will gives us 2.6875. okay, so here you can write 2.6875. okay, so you can say that a required root is x3 is equal to 2.6875 at the end of third iteration. Okay, in question if it is given you have solve up to fourth iteration, you have to solve up to fourth iteration. okay, if it is not given, you may solve up to third iteration. Okay, and after third you can say that required root of the given function is x3 is equal to what value we have obtained. Okay, so this is an example of a bisection method of a logarithmic function. Okay, now for homework you may solve examples on bisection as find a root of e raised to minus x minus x equal to 0. Okay, so for, or you may also write it as, if after solving it can be written as 1 upon e raised to x minus x is equal to 0, or it can be written as, here you can also write or as, after taking LCM it will be 1 minus x e raised to x, and denominator, whole denominator is e raised to x, and shifting on right side it is 0. Okay, so you, for f of x is equal to 1 minus x e raised to x and e raised to minus x, both this function will give a same answer. Okay, so you may solve by using f of x is equal to 1 minus x e raised to x, okay, equal to 0. Okay, so here first you have to find the interval in which it lies, and after that you have to solve for a root. Okay, so sorry, we will solve here only. In next lecture we will study about regular false next method, or method of false position. So we will solve this example. Now here you have to check the value in which f of x lies. Okay, so for f of 1, in rough calculation you may solve it. For f of 1 it will be 1 minus 1 into any term is 1 into e raised to 1. Okay, so it will gives us as, when we solve it, it will be gives 1 minus e raised to, now here it is e raised to 1. Okay, so it will gives us minus 1.7182, okay, which is less than 0. Okay, and for, you may also check for f of 0. You first start from 0 only. It will be 1 minus 0 is 0. Okay, x is 0 into e raised to 0. So here it is 0 into e raised to 0. It is 0, so it will be total term 0, and 1 minus 0 is 1, which is greater than 0. Okay, so from these two you can say that a root f of 0 is equal to 1 minus 0, which gives us 1, which is greater than 0, and for f of 1 it is 1 minus e raised to 1, which is equal to minus 1.7182, okay, which is less than 0. Therefore f of 0 and f of 1 have opposite signs. Therefore root lies in interval 0, 1. First we take an initial approximation. So here you can take x naught is equal to 0 plus 1 divided by 2. Okay, because root lies in interval 0 and 1, so we have to add it and divide it by 2, which will gives us 0.5. Okay, so f of 0.5 will be f of 0.5. Now you have to replace x by 0.5, which will gives us 1 minus 0.5 into e raised to 0.5. Okay, on calculator we have to take an calculation. So here it is 1 minus, here it is e raised to 0.5, and we have to multiply it by 0.5. so here I have make a mistake, sorry, I will make it again. 1 minus 0.5 into e raised to 0.5. okay, so it will gives, you have to make a double bracket, and it will gives us 0. So its calculation is 0.1756. okay, 0.1756. so which is greater than 0. Now here interval is from 0 to 1, and at 0 it is positive and at 1 it is negative. Okay, so for 0.5 its value is a positive. Okay, so our next interval will start from positive 0.5 and ends at negative, and it is 1. So here you can say that x naught is not root, x naught is not root if the value is equal to 0. Here if it is equal to 0, you say that it will be a root of a f of x. Here it is not equal to 0, it is greater than 0, so it is not a root. And at iteration 1 you may solve it by f of, since you can say that f of 0.5, and here it is positive and at 1 it is negative, have opposite sign. So root lies in interval 0.5 comma 1. okay, so x1 is equal to 0.5 plus 1 divided by 2, which will be 1.5 divided by 2 is 0.75. okay, now for f of 0.75 it will be 1 minus 0.75 into e raised to 0.75. okay, so we have to find the value of f of 0.75, and we have to check it is positive or negative. So here 1 minus 0.75 into e raised to 0.75. okay, and its calculation will be negative minus 0.5877 minus 0.5877, which is less than 0 again. okay, so here our interval was 0.5 to 1. okay, 0.5 to 1, and at 0.5 it was a positive and at 1 it was negative. Now here its midpoint is 0.75, and at 0.75 it is again negative term. okay, it is negative. Now our interval will be from 0.5 to 0.75. okay, so next iteration, here you have to say that x1 is a not root, and iteration 2, in iteration 2 you may say that f of 0.5 and f of 0.75 have opposite signs. So you can say that root lies in interval 0.5 and 0.75. okay, so x2 is equal to now 0.5 plus 0.75 divided by 2, which will gives us as, now addition of these two is 0.5 plus 0.75 divided by 2. Its calculation will be 0.625, which means midpoint of 0.5 and 0.75 is 0.625. Okay, so here at 0.5 it is positive and at 0.675 it is negative. We have to find, well, function is positive or negative at 0.625. So we have to find f of 0.625, which will gives equal to 1 minus 0.625 into e raised to 0.625, which is equal to, so its calculation after solving is minus 0.1676, okay, and which is less than 0, okay, which is less than 0. So you can say that it is negative at 0.625. Therefore x2 is not root. Okay, so we have to go to next iteration number 3, and this you may say that f of 0.5 and f of 0.625 have opposite signs. Therefore you may say root lies in interval 0.5 comma 0.625. Okay, so therefore x3 is equal to 0.5 plus 0.625 divided by 2, which will gives us as 0.5625. Okay, 0.5625, and you may say that x3 is a root of f of x, or you may say that here I will write it here, that is 0.5625 is a required root after at end of third iteration. Okay, you may stop here. Okay, so for today we have studied examples on a bisection method. Okay, so for today we will stop here. Thank you.